Hi, my name is Ruhi Kaul and I'm 14 years old. I'm from Mississauga, Ontario, in Canada. I have experience in different types of sciences, including human biology, theoretical physics, and astronomy. My experience is very useful for this mission to perform experiments. My strengths include problem solving and resourcefulness. These skills are important, especially because Mars is very different compared to Earth. Problem solving enables me to help the team to get out of tough situations quickly. Resourcefulness is useful to make use of the equipment we already have.
Hi, my name is Abdullah Abdul Samad. I highly excel in two skills, which are constructing/engineering and computer and technology. I believe engineering is an extremely crucial skill because spacecrafts aren't perfect. They have malfunctions and parts get destroyed, or sometimes new parts are needed. And that's when I can provide the crew with help, because I can replace, design, and build new parts to keep the space shuttle in a sustainable state. Now, for the second skill I provide is I have some expertise in computers and technology. This means I can make sure all systems work fine, and in a case of emergency, I can always control the technological aspect of the whole system. I also have a very positive trait, which is great collaboration skills, meaning I can work well with the crew.
Hello, my name is Finn, and I am proficient in two skills that would help me through my journey in space. I exude proper judgment in high risk situations through my involvement in many sports. Making the right decisions when it comes down to the line is something I am familiar with. This skill is very applicable in space, as wrong decisions or the failure to act doesn't just mean you lose the game, it means you and your crew could die. From my time in tech class, as well as other projects at school and home, such as the Peel Skills Challenge, I have dozens of hours of experience in mechanical tasks. This knowledge would help me to navigate the many machines the expedition would provide and would also make me equipped to repair damaged equipment.
Hello, my name is Hannah Alai. I am certified in CPR and first aid. I am a pretty kind and caring person who can get along with most people, which is helpful when I have to live and work with the same people every day for 3 years. I am resourceful and creative and can think quickly in stressful situations. This is a handy skill because the job of astronauts can be quite stressful at times and we need to think our way out of many problems. I can use logical reasoning and analyze problems from a scientific or emotional perspective depending on the situation. I enjoy learning about science, especially in the field of astronomy. I'm an extremely curious person, and my ability to look at information through different perspectives helps me analyze data in a unique way, which is a useful trait for a scientist exploring a new planet.
This star, also known as Alpha Scorpii, lies about 550 light-years away. It's the brightest star in the zodiac constellation Scorpius the Scorpion, which is figured prominently in the lore of ancient cultures. Antares is often called the Scorpion's heart. Nowadays, we are aware that Antares is a red supergiant star in the last stages of its life. Antares has an M1 classification, meaning it is reddish in color. The color of stars gives an indication of their temperature. Proportionally hot stars appear bluish, while proportionally cold stars appear reddish. This means that Antares is much cooler than many other stars. Its surface temperature is estimated to be around 3,400 degrees Celsius, in contrast to the Sun's temperature of about 5,800 degrees Celsius. The star's apparent magnitude, that is to say its brightness as measured from Earth, is 0.96, and its absolute magnitude, the apparent magnitude of the star, if it were 33 light-years away from the observer, is negative 5.2. To determine a star's composition, scientists use a spectrometer to analyze its spectrum. They can then compare the star's spectrum with known spectra of elements. Much of what we know about stars today comes from using spectrometers. The spectra of stars can tell us which elements make up stars and can also serve as an indicator of stars' temperature. From comparing Antares' spectrum to other elements, we know that it is mainly comprised of carbon. The composition of the star can also allude to its life cycle stage, where the density of its main elements tells us how far into the cycle the star is. Younger stars mainly consist of hydrogen and helium, where older stars move on to fuse carbon and iron in their core. Scientists have a good understanding of the life cycle of stars. They are aware that stars burn through their hydrogen fuel, puff up, and eventually expel their gases into space, whether with a bang or a whimper. However, the mass of a star determines at what age the star goes through each cycle. More massive stars die young, while less massive stars can burn for billions of years. At the turn of the 20th century, two astronomers, Ejnar Hertzsprung and Henry Norris Russell, independently came up with the idea of comparing a star's temperature with its brightness. The patterns on these Hertzsprung-Russell or HR diagrams correspond to the positions of different stars in that lifetime. Today, scientists use these patterns to determine the age of star clusters, whose stars are thought to have formed around the same time. By the 1970s, astrophysicists noticed a trend. Stars in young clusters were spinning faster than stars in older clusters. In 1972, astronomer Andrew Skumanek used a star's rotation rate and surface activity to come up with a simple equation to estimate a star's age. Rotation rate equals age minus 1/2. This was the best method for providing individual stars' age, until it was realized that certain stars don't slow down after reaching a certain age, and instead keep the same rotation speed for the rest of their lives. Rotation is the best determiner for stars that are younger than the Sun, but for stars older, it is useless. Watching stars twinkle can provide clues about their age. Scientists view changes in a star's brightness as an indicator of what's going on beneath the surface. and use modeling to roughly calculate the star's age. To do this requires a very large data set of star brightness, something only very precise telescopes can provide. Through these various methods, we are aware that Antares is a member of the Upper Scorpius subgroup of the association, which contains thousands of stars with a mean age of 11 million years.
Mission 3. Preparing for emergency situations. The atmosphere of Mars is 96% carbon dioxide. To survive for a year, the 4 astronauts would require approximately 1 metric ton of oxygen. The gravitational pull on Mars is much less than it is on Earth. That means that the oxygen tanks would weigh much less on Mars. However, the weight would still be significant. This is why scientists have developed the Mars Oxygen In Situ Resource Utilization Experiment, also known as MOXIE. It converts carbon dioxide from Mars's atmosphere into oxygen. Water supply. A cycling system mixed with water from Mars and water from Earth could be used to produce water for the entire trip. This would minimize the amount of water being carried by the shuttle. The cycling system would capture wastewater and filter it until the water is drinkable. Water on Mars is stored in shallow ice deposits under the surface. Water mixed from Earth would provide an important sense of normalcy for the astronauts. Food supply. Food in space must be at least one of the following. Most of the food consumed in space has been treated to increase its shelf life. All of the food has been carefully approved by dietitians to make sure astronauts have a balanced diet and to make sure they are not consuming too much calcium or potassium. And this is to make sure that they have healthy bones, healthy muscles, and an overall healthy body. Gravity assist. That's a maneuver where a spacecraft gets a speed increase or a direction change by moving past a planet. There are 2 main methods to reach Mars. The first is a conjunction mission in which the astronauts wait for Mars and Earth to align their orbits. The second mission is known as an opposition mission, where the spacecraft would slingshot past Venus using a gravity assist to change course. The benefits of this type of mission would be that if something were to go wrong, using Venus to change course would allow for a much faster return to Earth. As well, the team could also be exploring Venus. Communication in space. NASA communicates with spacecrafts using a transmitter and a receiver. They also use the Deep Space Network, which is a collection of radio antennas that are evenly spaced across the globe. The limitations of using these radio waves include that the waves are more crowded and that radio signals degrade with distance. This is why NASA is developing ways to communicate with infrared lasers. There are many maintenance tools required when in space. First, larger tools make work in big space suits easier. The second most important maintenance tool would be the dry film lubricant, which is used instead of wet lubricants and can withstand harsh temperatures. It allows parts to slide and allows them to work in good working order.
Space radiation. What is space radiation? Radiation can come in 2 forms. Ionizing radiation has high energy. Non-ionizing radiation has low energy. Ionizing radiation is far more dangerous than non-ionizing radiation. Where does it come from? The sun is the largest source of radiation for Earth. An event known as a solar particle event, or SPE, occurs every so often. These events are massive explosions on the surface of the sun. What effects radiation has on astronauts? So here are some impacts and symptoms of radiation in space. There are 2 countermeasures against radiation that will help on our trip to Mars. Engineering countermeasures are mainly means of blocking radiation. These can include shields and tools that reduce the amount of radiation that reaches the astronaut. On Mars, Martian water could provide good shielding. Materials such as polyethylene are also good at blocking radiation. Dietary countermeasures are drugs or specific foods that astronauts can ingest. They come in 2 groups: drugs that protect against radiation damage and drugs that speed the recovery from radiation damage. There are drugs that soak up radiation before it does too much harm, drugs that can speed up how quickly the body rids itself of radiation, therefore reducing how much it absorbs, and more. The other group of drugs is responsible for recovery from exposure to radiation. This includes drugs like radioprotectants, which are good for speeding the body's natural healing process. Conclusion. As of now, there's no way to keep astronauts completely safe from radiation. Even when the rocket lands on Mars, it's not entirely safe from radiation. This is because Mars has a thinner atmosphere and lacks the magnetic protection provided by Earth. Mars has an average radiation exposure of 240 to 300 millisieverts per year. This is higher than the maximum radiation exposure laid out by the International Commission of Radiation Protection, which is 50 millisieverts per year. With our countermeasures, radiation shouldn't be an immediate threat to the astronauts' lives. Solar heating on Mars. Introduction to solar heating on Mars. First of all, a base on Mars would require really good insulation, both to keep the warmth in and the cold and dangerous radiation out. Then a heating system is required. Different kinds of solar heating. There are two different kinds of solar heating, passive and active heating. There's also photovoltaic heating, which uses solar panels to make electricity, which powers heater elements. This energy can also be stored for later use, which is helpful during the night. These systems will be able to heat up a base on Mars. 3 other pieces of equipment we will need. There are many pieces of essential equipment that would be useful on a mission to Mars, but here are my top 3. 1. A battery to store solar energy for use in the night or during a dust storm. Electricity is important because it powers life support systems, lights, and more. 2. Spare parts. This is because an equipment malfunction could be fatal on Mars. It's important to know which parts are likely to break so we can take spares, as well as how to best fix equipment so that the least amount of parts are wasted. 3. A tool for communication over vast distances. A method of communication would be extremely useful if an astronaut finds themselves in danger or in need of assistance a long way away from the rest of the team.
Firstly, Mars has a diameter of 6,780 kilometers. This means Mars is almost half the size of Earth. So a day on Mars is about 24.6 hours, or 1,477 minutes, or 88,620 seconds, meaning that is how long it takes Mars to completely spin once. Now, for a full orbital period of Mars, it takes Mars about 687 days to orbit the Sun, meaning a year on Mars is almost double a year on Earth. Next, the distance from Mars to the Sun is 228 million kilometers. In scientific notation, that's 2.28 times 10 to the power of 8. In astronomical units, it's 1.5 AU. In light years, it's 0.00002371. Next, the average distance from Mars to the Earth is 225 million kilometers. In scientific notation, that's 2.25 times 10 to the power of 8. In astronomical units, it's 1.504 AU. And in light years, it's 0.00002378. Now, Mars has a very elliptical orbital radius, meaning it's more of an oval-shaped orbital path, so even though the average orbital radius of Mars is 1.5 AU, the orbital radius of Mars can vary from between 1.38 to 1.67 AU, depending on its location. So, the gravity of Earth is 9.8 meters per second squared, and the gravity on Mars is 3.721 meters per second squared. Now, this is a very special phenomenon that takes place about every 26 months. Earth will overtake Mars, and what this basically does is when Earth passes by Mars, it will appear as if Mars is moving in weird patterns while in orbit. Usually the patterns that we see from Earth is that Mars forms a curved, zigzag, or loop pattern in its orbit path. But this is all just an illusion because as Earth moves along its orbit, moving away from Mars, Mars will seem like it's back to normal. This is the effect called retrograde motion. Now, Mars' surface rock has a mineral composition primarily made up of elements such as iron, silicon, oxygen, and magnesium, and elements such as titanium, manganese, chromium, and sulfur are less abundant. Mars is also a terrestrial planet. Now, Mars' atmosphere has 96% carbon dioxide, less than 2% is argon, less than 2% is nitrogen, and less than 1% is other gases. Now, because there's very low oxygen and a lot of carbon dioxide in Mars' atmosphere, humans wouldn't be able to breathe on Mars. Now, Mars does actually have an aurora borealis because it has an atmosphere, and the color of it is almost ultraviolet glow, which is a blue glow. So, Mars in fact actually has the same seasons as Earth, but Mars' seasons are longer. The average temperature on Mars is negative 62 degrees Celsius, and these temperatures are caused because of the thin atmosphere. Now, yes, in fact, Mars is very well known for its dust storms because of how severe they can be, and these dust storms aren't regular dust storms. After the storms, dust can take months before it settles back down. Now, there are 2 moons that orbit around Mars, and they're called Phobos and Deimos. Now, there are 8 phases of the moon on Earth. New moon happens when the sun is reflecting on the far side of the moon, which is what we can't see, and a full moon happens when the sunlight reflects on the near side of the moon, and the rest of the phases occur when the sun reflects partially on the near side. So there are 2 types of lunar eclipses on Earth. A total lunar eclipse, when Earth casts a shadow over the moon covering the whole moon because the moon and the sun are on opposite sides of the Earth, and then there's partial lunar eclipse, which is basically when only part of the Earth's shadow covers the moon. So firstly, let's talk about Phobos, the larger and the closer moon. This moon casts a relatively small umbra as we can see from the diagram, and the picture, the shadow casted barely reaches the surface, casting an extremely small shadow. Now the second moon, Deimos, is the smaller and the more distant moon, therefore it doesn't even cause a solar eclipse. So mainly the difference between them is firstly, comets are very easily identified from the other 2, as comets are mostly made of ice and often have a halo tail. So the difference between meteorites and asteroids is meteorites often hit a planet's surface and are found on Earth. But the main identificational difference between the 2 is that meteorites are pebble-sized, whereas asteroids are smaller than planets and are called planetoids. Yes, there are many of these celestial objects between Earth and Mars, and here are some of them. Comet Ison and Comet Siding Spring, Amor asteroids, which is a group of asteroids, and lastly, some meteorites are Chingi and Shergodi meteorites.
Based on the facts above, we support building a space station on Mars.